So, Romit, over to you.
Yeah. So good afternoon, everyone. I'm Romit Kaware, a research fellow at MRC and pursuing my undergraduate in civil engineering from IIT Delhi. So today I'll present about the sediment classification, its application, and some about the policy interventions in the tropical waters. So our discussion will be about some sediment classification, some introductory part about it, then the three major areas of interest we will talk about, and then we will see what are by the policy interventions are needed in the tropical waters. Can be formulate a policy formulation can be done, and then some concluding remarks. So one of the first question that comes to our mind is why should we like study the seabed? So the complex nature of the seabed is like due to the various processes that had occurred in millions of years. Due to this various recreational, economic, military, and oceanic applications need the qualities of the sediment or the seabed. And then for locating the various the marine environment and the operation of the various structures, say drilling rigs or oil rigs are there, many support structures. They require the geotechnical applications of the sediments. The density or the moisture content, the shape, size, structure are also needed in order to have proper construction of these offshore structures. The seabed structure is also vital for planning the submarine routes, as well as different marine environments are also characterized by the sediment type that is present at that particular location. Hence, it influences what are the various abiotic and the biotic components in the marine ecosystem. So, we have been like studying the like seabed and conducting research activities for like many decades now. So conventionally, if we have to conduct some test and all, the detection site is located and then physical samples are being extracted, and then many tests are conducted based on what is the application, what are the needs and all. But again, these tests are conducted by having some we have corers and grabbers are there. So there is a vibro core sampler or box sampler is there. So all these samplers are there which may physically extract the samples and all, but again these are limited in scale, time consuming, and as well as maybe expensive as well. So like more recently there has been remote sensing based acoustics classification system. So they use the various sonars and all, and has a lot broad coverage as well as is like cost effective as well. So these are the new modern day techniques that have evolved. Now apart from all these technologies, we also need to identify what are the corresponding stakeholders, have proper consultations with them in order to have a holistic development without any delays and all. And in order to do this, we also need to understand what are the various policies that are there in place when we consider the global, regional, or the national scale, and to understand what are the policy gaps that are there when we come to the Indian Ocean region. So, like with the development of the various technologies and all, a lot of interest have been developed in the many applications of the seabed. So we see that the exploration and extraction of the various minerals or other resources require offshore construction, support structures and all, and these are all like supported by the foundation. So these foundations are like how can we design them? The strength of the foundation or are determined by the sediment bearing pressure. So it is significant in the design and detailing part of how the site would be selected, what kind of process needs to be involved for constructing the particular structure and all. The other one is there is a lot of marine resources when we consider the living resources. So they are exploited with the benthic boundary there in the lowest part of the ecosystem in the particular water body. So their management also becomes crucial as we need to establish what is the particular, we need to identify what is the health status and all, monitor and maintain our biodiversity and all. Another part is that a lot of trash deposits, say marine litter, is been like floating around our oceans. Like a lot of pieces are there, and they may cause a lot of problems to the marine ecosystem as well. Hence, we need to identify them and then choose parts of recovery needs to be done. Then a lot of communication between the islands and the mainland is done through underwater cable, underwater transmission. They may be of commercial use or maybe of military use as well. So planning these cable routes also is another interesting application. Then with the improve like technology is evolving day by day, and with like a lot of stress on existing resources, there has been new mineral oil gas resource explorations in the untapped regions of the Indian Ocean region as well. So all these are the various interests that are there in the seabed. We will talk about three of them. The first one being the sediment bearing pressure. So the sediment bearing pressure is the sediment bearing pressure is basically the pressure that can be exerted on the sediment which is in contact with the seabed which is in contact with the seabed. Now the pressure that can be exerted or can be like taken by the sediment depend on the characteristics of the sediment, say the moisture content, density, the roughness, and the texture of this sediment as well. Thus these sediment bearing pressure is necessary in order to have a good engineering and geotechnical investigations about the various foundation design, retaining wall, or the seismic soil stabilization as well. It is necessary to like have these sediment bearing pressure analysis in mind in order to have a safe and secure structure which will not collapse or fail under excessive settlement. Thus, the structure may be of like strategic importance or economic importance as well. So, example, if the army wants to deploy some amphibious vehicles or set tanks in a subtop in a like shallow water region, so they may require what is the sediment bearing capacity of that particular region, or else the assets which they are going to deploy, they may sink. So this kind of studies have extensive military applications as well. So when considering how can we calculate the sediment bearing pressure conventionally, what happens is we have a detection site, ships वगैरह are sent, and then they physically extract those samples, and then based on what are the parameters that are needed for the calculation, extensive laboratory tests are performed. So there have so many tests may be performed, triaxial tests may be performed on them to determine what is the strength of the sample, or to characterize what is the texture, and classify it on based on the grain size and all. But again, as I mentioned, these are time consuming and do not have a lot of coverage as well. So that's why these acoustic systems which deploy the use of the various side scan sonars, multi-beam echo sounder, or the sub-bottom profilers, they can be used because again they have broad applicability as well. So like this in the image you can see, these can be mounted on AUV submarines on or ships depending on the specific needs and the resources that are available. Again, this image shows how like these acoustic systems, they're complemented by having some mathematical models or some data analysis models as well. So this is one of the model how the input data is taken, then what are the various processes through which it can go in order to have different parameters to be determined. Correction factors as well can be determined. And this is a conventional borehole data of the geotechnical investigation of the soil to classify what type of soil it is, at what particular depth, or what is the soil type, what is its classification, then what are the various sediment grain size classification is present. So this is one of the conventional way that it can be done. So coming to the policy part, what are the various policies that govern the construction in the mostly in the exclusive economic zone region of a particular coastal state? So for this, the United Nations Convention on the Laws of Seas, their UN clause, it has various guidelines for like managing the oceans, including the EEZ, the seabed, subsoil, and the water column as well. The International Seabed Authority is there, which has mandate to regulate activities in the international seabed as well. In the construction part, it has various regulations and like activities for the exploration and exploitation of the particular international seabed, and then how can the environmental impact assessment be carried out, what are the various monitoring and reporting guidelines, safety standards for the various operations, these are all mentioned. Apart from this, the convention also has the various articles. So article 56 has provided the coastal state with the various jurisdiction in regards to the construction or the establishment of the artificial island, offshore construction installations and structures. Article 60 has also some relevant provisions regarding the same. Coming to India, there is the Territorial Waters Continental Shelf and Exclusive Economic Zones Act, which has the legal framework for managing and regulating India's maritime like zones, which includes construction in the EEZ as well. There is the Coastal Regulation Zone, which has like the under the Environmental Protection Act has various guidelines for coastal zone, and for construction activities in the EEZ, what are the various requirements for obtaining environmental clearances and all. Then there's the EIA notification, which involves that any construction activity which may cause a significant environmental impact should have an EIA done before it should be like approved. Then there is again the National Green Tribunal dealing in cases of environmental law disputes as well. So there are a lot of policies internationally as well in the national level as well. So coming to our next area of interest, that is the benthic ecosystem assessment. So benthic ecosystem is the ecological niche lying in the lowest region of the water body and is in contact with the substrate or the bottom. They are necessary because they not only help in the nutrient cycling and energy transfer, but they also help in identifying and monitoring the health of the ecosystem that is present. We need to monitor these benthic ecosystems in order to like firstly see the natural variability of these particular benthic ecosystem, then to see what are their variation with respect to many other natural factors, say ocean warming is there, and then in order to have a time series or a future predictability on how the various risks associated with the current scenarios would affect these benthic ecosystems, or we can say these ecological assets. So that's why these monitoring systems are required. So again, when we come to the technology part, how can we identify these benthic ecosystems? So the traditional methods involve having biological samples there. There would be sediment grab samples or radars would be there, or there would be rapid visuals assessments of the particular parameter by diving surveys as well. Now with again use of technology, with the development of technology, there are these acoustic sensors, which use again we can use the side scan sonars and all. These can be mounted on the AUVs or the remotely operated vehicles as well, so that they can be pre-programmed in order to investigate some isolated areas. And then there are various benthic indicators as well. So depending on what region you want to identify, what type of species you want to identify, different types of indicators are developed to determine the health of the particular benthic ecosystem. So there are like most of them are in the Mediterranean region as well. Then with the like large scale there is a need for a large scale spatial data on these benthic species as well. So various computational simulation and modeling techniques have also been developed. One of them is the distribution modeling techniques that has been developed, which lead to a like a full scale prediction of the spatial benthic ecosystems as well. So basically all these technologies, and they all depend on what are the various users need, what or input parameters are needed. So we need to understand the more larger source path receiver model. So basically what are the various input parameters you need, what are the parameters you need to study, how are you able to collect the data, source the various data, then through which path you want to analyze the data that is there, and then depending on the receiver, how you want to visualize it, how you want to show it to the receiver. So there are three aspects in this: the 2C, to understand, and the 2 share aspect. So in the 2C aspect, we would like to see what kind of sensor needs to be used, what hardware needs to be sourced, what are the various techniques. Do we need to go to acoustic path or through optical technique way, how we need to be deployed those sensors, either they need to towed by submarines, ROVs, or be mounted on ships, be towed, how we need to what vehicles need to be deployed, and what is the specifications of these sensors, because like depending on the acoustic sensors, depending on the frequency, different so the range of the depth through up to which we can determine or classify these sediments, they also vary. So what are the specific specifications of the sensors used? Now once we have the data and we have collected it, The next part is how can we interpret the data based on what the parameters are needed. So there may be a lot of data pre-processing, post-processing, a lot of data analytics which involve the use of machine learning or artificial intelligence, like some use unsupervised learning, supervised learning, some mathematical models like in the sediment classification there is a Bayes-Stall model, it can be used. So what kind of, do you need a Fourier transform series and all? So depending on the specific needs, how these data processing techniques needs to be used, needs to be like analyzed, and then according to what type of user is there, what is their need, we need to show them differently what type of data. Like yesterday Arnab sir told, if a policy maker is there, the policy maker would require to have some data of some decades or maybe 100 years. So how on what time scales we are trying to represent to data. Some user may require the data on a some, we need to develop some web based graphical user interface, or some would require a mobile application to for the data to be presented, or some, or for some application maybe on the hardware itself the data needs to be presented. Again, how can we show the data through maps, tabular, through tables and all. Again, in this the marine special planning would come to our rescue. So basically then what kind of application it is. So again, the Navy would have some different specifications of data than a researcher, and some may require a real-time data feed. So how can we share this data? So all these aspects are different research topics at all. So depending on what type, what is the main focus of this research, different research techniques can be used different. So yeah, that's the main thing we need to consider. And then this is the the distribution modeling method, the computational simulation, how it basically shows how the concept may be done, how various input data can be carried, then how the model parameters can be thought of, what are the various model parameters, and then once we have some predictions, how can we use them to monitor them. We could predict some future scenarios as well. How can marine special planning be used in it? And also again, a lot of planning and policy formulation would also go into it. Now the image on the left, this is an reconstruction of a particular coastal landscape from an UAV survey, while on the right you can see the digital elevation models of a particular location. Through bathymetric surveys they have been able to reconstruct the topographic scale as well. So again, these techniques would help us in order to map our seabed in extremely new ways. Now uh, coming to the policy part. So like most of the international community has been there to like have various policies in areas which are beyond the national jurisdiction as well. So internationally we have the International Union for Conservation of Nature. It has the ocean governance, which has various processes and agreements in place for the protecting areas which are beyond the national jurisdiction as well. The Convention on the Laws of Seas, it has dedicated part 12 for providing legal protection on the marine environment as well. There is the Article 207, which has duties of states towards the rejuvenation and the preservation of these marine ecosystem. The Article 208 talks about the various seabed activities and how the human activities would lead to the various survival of the benthic communities as well. Coming to the India, we have the Article 48A and the Clause G of the Article 51A, which like mandates the state to protect the forest and wildlife of the country, which includes the marine ecosystem as well. The Environment Protection Act is there, which like there is the Water Act, which banned industry from trying to pollute the environment and the marine ecosystem as well. In the US, the Environment Protection Agency also has various guidelines in order to how can we monitor, assess, conduct surveys of these benthic ecosystems. In the EU, the Marine Strategic Framework Directive, it directs the EU member states to like assess and monitor their marine environment to achieve a good environmental status, its biodiversity, and its seafloor integrity as well. So again, nationally, regionally, globally, a lot of these regional agreements are in place. Now, we also look into a case study in order to look why such policy formulations would pose some kind of uh, complexity as well. So, there was a case study in which they basically wanted to know the ecological status of 700 sites in the Mediterranean region. So, as very little quantitative data or research data is there, which they needed to have a comprehensive study which would represent the actual health of the marine ecosystem in the Mediterranean region. So, again, what the researchers tried is that they took four major habitats, and then, as I mentioned, there are various benthic indicators. So depending on what type of region they wanted and what type of species they wanted to assess, they used this indexes like the rapid easy index or the Carlet index, and they also calculated the ecological quality ratio. So the basically the ratio of the indices at the specific site and to the indices at the reference site. This study, however, highlighted that there are differences in this habitat classification system, monitoring methods, and the threshold methods that are there between the various nations. This hindered the actual representation of how the ecosystem is getting degraded. Also, there are a lot of indicators that are being used which are making the comparisons difficult, thus impairing how to have a reliable and an extensive picture of the health of this particular benthic ecosystem. Thus, according to them, there was an urgent need to achieve a consensus on which type of data needs to be collected, what indicators need to be used, how can we classify them based on the marine ecosystem health, because the current policies are too fragmented based on the various decision makers, the nations, the researchers, the policymakers, and the practitioners as well. So again, a lot of agreements or a lot of indicators in place lead to more complexity. Now, coming to our next application, that is the abiotic element detection. Now, it is one of the most crucial parts which involves identifying and locating objects which are not part of the natural seabed environment, which may include lost or discarded items or wreckage from ships as well. Plastics, which also considered a major part of marine litter, are like just lying across our oceans and all. So this forms a major part of this abiotic elements. Another one are the polymetallic nodules. So there are manganese, cobalt, or copper, which are present in good quantities in the Indian region as well. In potato-sized nodules, which are called as the polymetallic nodules. So these are also of various commercial viability as well. For some facts, India was the first country to receive the status of pioneer investor in the 1987 and was allotted an exclusive area in the central Indian Ocean for this polymetallic nodule utilization. In fact, India is in the top 8 countries which is implementing a long-term contract for this exploration of these polymetallic nodules. So again, you can use these new modern machine learning algorithms as well. So you have some diving surveys and also, and then you can integrate these machine learning algorithms to have real-time classification of what kind of object it is, whether it is a say sea urchin and all, and then or a plastic object and all, or a rock. So depending on what kind of object it is, we can classify these abiotic systems as well. So again, this shows a conceptual model of how the marine litter can be, how can we understand the problems of the marine litter, how can we map them, we have some modeling techniques, how can the various stakeholders be brought in, how can the legislation involve in managing these marine litter, and then how can we recycle them, reduce them. So basically all of them are involved in a particular strategic planning. So again, coming to the capability part. So again, if we need to conventionally see what kind of litter is there, we would have some grab samplers in the particular detection place. We have these crawler systems. So these have some, excuse me, these are some crawlers which would be there. There are pumps, vacuums which would then take in those systems, recover these some of these samples in order to have extensive laboratory testing and all. Again, there would be diving surveys in order to visually inspect if some of these techniques may not be able to effectively classify. Now, with the rise of these acoustic systems, we can use sonar, or some of these foreign objects would also have magnetic properties which could be taken up by the magnetometer. So we could have magnetic surveying as well. Again, we could have videographic surveys, optical imaging, or with the growing technologies, the use of machine learning, we could have some researchers tried to integrate the machine learning algorithms. Like you only look, one model was there, some use the regional proposal network RPN, while some use the faster RCNN networks in order to integrate them with the video surveys that were conducted in order to have a proper classification system in place. So these could be again, these videographic surveys would again be conducted by placing them over AUVs or ROVs. They could be like pre-programmed or again autonomous. So yeah, with growing technologies, we could have proper like location and identification of what kind of marine litter is there, and then proper recovery methods could be developed. Coming to the policy part, so according to the convention of the United Nations Convention on the Laws of Seas, so it has various laws for the seabed and ocean floor, and how can we use its resources, and then these resources are common resource for the humankind, so they must be effectively used, and not a lot of pollution be caused. Then there is the International Convention on the Prevention of Marine Pollution from Ships, or the MARPOL, which is developed by the International Maritime Organization. Coming to the EU, there was the Barcelona Convention in 1976, which aimed to protect the Mediterranean Sea against pollution, and preventing and eliminating pollution by dumping from ships and aircraft or by incineration at sea. In India, the Ministry of the Earth Sciences, along with the National Center for the coastal research of this temporal and spatial distribution of marine litter in the along the Indian coast and the neighboring seas as well. The Ministry of Environment has the plastic waste management rules, under which like they have prohibited the manufacture or stocking, import or distribution of plastics that are less than 50 microns thick, in order to in order to prevent this marine litter going into the our Indian Ocean region as well, which may cause harm to the marine ecosystem as well. So having seen that a lot of these policies are there in place, say nationally or regionally or internationally, so we need to know why do we really have some policy frameworks in the Indian Ocean region. So we may first look at some facts of the Indian Ocean region. So the Indian Ocean region is one of the busiest tanker route in the world, carrying around 500 million metric tons of oil. Now most of this oil may get seeped into the or may get there may be some oil slips which may cause a lot of damage to the coastal environment and the mangrove forest along with the coral reefs as well. And then again, the Indian Ocean region is abundant in the manganese nodules as well. There is a high concentration of the politically unstable, governance deficit, and the conflict-prone nationalities as well. So there is Indian Ocean region is an very interesting and unique place because it is of commercial and military application of the coastal states, as well as every other major power of the world as well. So again, there has been a lot of uh, when considering the various international conventions that are in place, a lot of problems have also been come up. So like there many observers have noted that there are a lot of reception facilities in terms of their high usage cost are there, and so many of the shipping companies tend to they just ignore the Marpol convention, and then they and then dump their litter overboard. Many of them, the Indian Ocean region countries also have less agreements in place when we compare them to the European counterparts, or we say the United States as well. Many of these countries though have their respective laws and regulations, but again they are governance deficit and are largely ineffective to in mitigating the illegal, underreported and the unregulated fishing as well. We also need to consider the Indian Ocean region countries have some of the most polluted rivers as well. So a lot of these rivers may dump their marine litter into the Indian Ocean region only. Again, many countries lack the proper standards, guidelines, and enforcement mechanisms owing to the limited scientific data as well. Again, there is not a single organization that would encompass all the Indian Ocean region countries. So there is the Indian Ocean Rim Association, but again it would like think of its focus would be on the like trade and not a lot of on the social political or the socio economical issues as well. So international, so regionally there have been a lot of problems regarding the international conventions that are in place. Now coming to the Indian part, there was like an issue said the Dharma port construction was there in Bhadrak, Odisha. So it also gained a lot of reasonable attention because like it was close to the vulnerable olive ridley turtle nesting place as well. So it also drew a lot of attention. Were there proper environmental consultations in place? Again, there are, since there are a lot of laws in the state on the state and the national level, there might be some kind of mismatch and a lot of complexity occurs. So there was a ship which had some toxic substances which was due to under the Indian coast. So the Gujarat Maritime Board and the Indian Customs they let it through pass, but the Ministry of Shipping and the Ministry of Environment sought further details. So there is a complexity and there is a mismatch of information as well. Again, there is a lack of capacity, skills, and access to cost-effective technologies that make it difficult to like overcome barriers of sustainable management of the aquatic resources as well. uh, Again, the region is concentrated with a lot of governance deficit. There are a lot of political conflicts as well. So there is a lack of regional trust between including the various countries as well. So we have seen that the ever-growing tensions are there in the our maritime neighbor only. So in the South China Sea, there is a rise of dominance over the particular Indian Ocean region as well. Thus, it is high time that particular frameworks are to be worked on for national interests. Uh, Again, else a lot of excessive delays are also led through some projects maybe of economic and strategic importance as well. So we saw the Mumbai Worli, there was a Worli sailing which saw excessive cost overruns, a delay in 5 years as well. Now, in accordance with the government of India's new vision by 2030, it highlights blue economy as one of the 10 core dimensions of growth. And so there is a need of a coherent policy which has different sectors which improve the lives of these coastal communities, accelerate development and their employment as well. Thus, India must recognize its position at an economic and strategic access and then strive for an efficient and sustainable utilization of these already scarce and untapped ocean resources in order to have these ocean related opportunities, capabilities, and then safeguarding the environment in regards of the UN sustainable development goals as well. Again, you can see this picture shows that when we come to the Indian Ocean region, it lacks in a lot of environmental baseline and the deep sea mining scientific gaps. So if anyone wants to have a proper study or research or formulate policies as well, the data is limited. Not a lot of data is available in the public domain. So there is a pressing need to have a like a formulation of the policy coming to the sediment classification framework. Now this could be worked upon utilizing the current floor which is given by the national framework for sediment management or the UDF framework, and then some extensions can be done upon which would include the blue economic policies as well, because the like as the G20 presidency is with India, one of its pillars is the blue economy, which is a more coherent issue coming to the global south as compared to the global north. The security and growth for all in the region, that is the Sagar initiative or the BIMSTEC, they are largely contributing for this advanced ocean cooperation and blue economic activities in the region. The blue economic policy also proposes to regulate various activities under the sustainable development goals and then bring in the private players as well, which could have a lot of investments and partnerships in the Indian Ocean region. The maritime sector is also going through an industry 4.0 revolution. So a lot of new technologies like advanced robotics, these sophisticated sensors are there, Internet of Things, machine learning, cloud computing. So all these are also required in order to have transform the marine sector and then have a greater growth and development. Now, keeping in view of the various stakeholders that are there, there needs to be a good consolidation between all those stakeholders. Upskilling of those stakeholders needs to be done with proper value addition as well. Thus, a comprehensive plan would also incorporate the freshwater systems to enhance the maritime security within our borders as well. Science and technology is also one of the key drivers of the safety, security, and the sustainable development of our oceans. Thus, it is important to know our what are our what do we do not know about the various undersea ecosystem, how the various interactions are there between the components of the marine ecosystem, and how human interventions are basically causing a variation in this working of the marine ecosystem and the total working of this ecosystem at all. So, in conclusion, I would suggest that India should leverage its position in the Indian Ocean region to have a proper policy framework, including the blue economy, the sustainable development goals, ensuring that there is peace, harmony, and security within the mighty Indian Ocean. So, with the comment of the former UN Secretary General Ban Ki-moon that the Earth is our only home, together we must protect and cherish it. I'll end my discussion. So, thank you.